Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of Cbse board exam, we'll be looking at previous year questions of mathematics in Cbse board exam. Today we're going to deal with integrals. This is the 7th chapter in the grade 12 syllabus for Cbse. In this chapter, we'll be starting out with integration, so stay tuned. We have a couple of questions which will surely bend your minds. Are you ready? Let's go. Here lies our first question. You need to evaluate the integral of x squared plus 1 divided by x squared plus 4 times x squared plus 25 times dx. How do you solve this question? That is our big question. In order to start solving this big integral, what we do is we replace x squared with t. Now remember that you should use the word replace when you're writing it in your exams. When you're writing the step, use the word replace. If you use the word put, then you'll have to find out then you'll have to change the limits and you have to find the integral of t, the derivative of t as well. So when you replace x squared with t, you don't need to find the derivative. If you're putting t as x squared, then you have to find the derivative. So this huge integral now becomes, instead of x squared, we write t. So t plus 1 divided by t plus 4 times t plus 25. So right now we can just discard the integration sign because we're just doing just looking at the value inside the integral. So right now we don't need to put in the integration sign. So it'll be x squared plus 1 by x squared plus 4 times x squared plus 25 will be equal to t plus 1 divided by t plus 4 times t plus 25. What do we do next? Use partial fractions. So t plus 1 by t plus 4 plus t into t plus 25 now becomes a by t plus 4 plus b by t plus 25. How do we simplify this further? Multiply both sides by the denominator of the left-hand side, which in this case is t plus 4 times t plus 25. You don't need to multiply any of these, just multiply this value of the numerator of the denominator to both sides of this equation. So therefore now you'll get the left-hand side as t plus 1 because the denominator gets cancelled. And in the first part, a by t plus 4 gets cancelled. So we get a times t plus 25. And then b, the t plus 25 part gets cancelled. So we have t plus 4 times b. Now we need to find the value of a and b. First thing you do, put t is equal to minus 4. When you put t is equal to minus 4, you'll get minus 4 plus 1 on the left-hand side, a times minus 4 plus 25 on the right-hand side, and the b term becomes 0. So because minus 4 plus 4 is 0. And that is our intention in order to find a. Therefore, what you'll get is minus 3 is equal to 21a. Therefore, a is equal to minus 3 by 21, which is equal to minus 1 by 7. So the value of a is minus 1 by 7. Similarly, we put t equals minus 25. This is to remove a. So what do we get? Minus 25 plus 1 equals a times 0 plus b times of minus 25 plus 4. Therefore, we'll get minus 24 equals minus 21b. So the value of b is now minus 24 divided by minus 21, which becomes 24 by 21. Both the minuses gets canceled. 24 can be written as 8 times 3. 21 can be written as 7 times 3. So therefore, when you divide both sides by 3, you get b equals 8 by 7. So the value of a is minus 1 by 7, and the value of b is 8 by 7. So therefore, t plus 1 divided by t plus 4 times t plus 25 is now converted to minus 1 by 7 divided by t plus 4 plus 8 by 7 in the numerator divided by t plus 25. Now, what do? Replace t with the original supposition. Here we replaced x squared with t. So therefore now we replace t with x squared in order to get our original equation. So that is x squared plus 1 divided by x squared plus 4 times x squared plus 25. It becomes minus 1 by 7 divided by x squared plus 4 plus 8 by 7 divided by x squared plus 25. So now we can integrate it on both sides. So integral x squared plus 1 divided by x squared plus 4 times x squared plus 25 dx equals integral of minus 1 by 7 divided by x squared plus 4 plus 8 by 7 divided by x squared plus 25, the whole multiplied by dx. So now we have our integral. Next, what is our step? It's pretty easy from now on. What we do is we separate the integral. So that is integral of, and over here we have minus 1 by 7. That is actually constant, so we can take it outside. So minus 1 by 7 times integral of dx divided by x squared plus 4. Similarly, it'll be 8 by 7 times integral dx divided by x squared plus 25, which we can write as 8 by 7 times integral dx divided by x squared plus 25 minus 1 by 7 times integral of dx divided by x squared plus 4, which is just the same thing. Now, how do we solve this further? If you notice both integrals, you are getting the integrals in the form of integral dx divided by x squared plus a squared. And what is the integral when you have such a combination on the left-hand side? You get 1 by a times tan inverse of x by a. This is our equation here. So integral dx divided by x squared plus a squared is 1 by a times tan inverse of x by a, just applying some properties. So when we put these properties in here, we get 8 by 7 times 1 by 25 is 5 squared, so 1 by 5 times tan inverse of x by 5. Then minus 1 by 7 times, here 4 is 2 squared, so it is 1 by 2 times tan inverse of x by 2. Now it's just a matter of multiplication of the fractions. So it becomes 8 by 7 times 1 by 5 becomes 8 by 35, tan inverse of x by 5, minus 1 by 7 times 2 is 14, times tan inverse of x by 2. This is our complete answer. But wait, where is the integration constant? We haven't added it out here. When we were integrating in these steps, we haven't added that constant. Well, don't worry. You can always add a plus c at the end in order to complete your answer. And that is actually a simpler way of doing things. Now that we have looked at our first question, here's another one. We need to evaluate the integral of dx divided by x times x cubed plus 1. It sounds like a tough one, but believe me, it's super easy. How do you start solving this question? Well, if you remove the integration sign and dx, what you're essentially getting is 1 by x times x cubed plus 1. And if you notice, 1 cube is always equal to 1. So we have a part of the denominator equal to a cubed plus b cubed. And what is the value of a cubed plus b cubed? It is simply a plus b times a square plus b square minus ab. This is, again, algebraic identity studied in grade 10 and applied in grade 12. So this whole value now becomes 1 divided by x times x plus 1 times x squared plus 1, 1 square, minus x times 1, so minus x. So basically, we have the value inside the integral sign as x 1 by x times x plus 1 times x squared minus x plus 1. Notice that once again, we can use partial fractions. So in this case, we get a by x plus b by x plus 1 plus, and since in the third part we have x squared, so therefore the numerator will become cx plus d divided by x squared minus x plus 1. Now what we do? Multiply both sides by x times x plus 1 times x squared minus x plus 1. So on the left-hand side, you get 1. On the right-hand side, you'll get a times x plus 1 times x squared minus x plus 1. Then on b, you'll get x times x squared minus x plus 1, because one of the parts is always getting canceled. And then for cx plus d, we are getting x times x plus 1. So now we can just simply substitute values for x in order to get our answer. In the first case, let's put x as 0. When you put x as 0, you find that this part here and this part here have now become zeros. So therefore, b and cx plus d will always become 0 when you put x is equal to 0. So both these parts we can ignore. So the value of 1 will be equal to a times 0 plus 1 times 0 squared minus 0 plus 1, again, 0 plus 1. So from here, we can get the value of a as 1. So a is equal to 1. Next scenario. We need to eliminate terms which have x plus 1. What do? You just multiply them with minus 1. Or instead, we can just put the value of x as minus 1. So minus 1 plus 1 becomes 0. The value of x is now minus 1. the only term which does not have x plus 1 in it is the term with b. So therefore, 1 equals b times minus 1 times 1 plus 1 plus 1. So this is basically minus of minus 1, and this is minus 1 the whole square. So square of negative is also positive, and minus of minus 1 is plus 1. Therefore, now you have minus 3b equals 1. So therefore, the value of b is minus 1 by 3. We cannot put the negative sign below. You have to always change it to the above. So minus comes here, so that becomes 3b is minus 1. B becomes minus 1 by 3. Now we have the values of a and b. How do you find the value of c here? Well, to find the value of c, instead of multiplying everything, we can just equate the coefficient of x cubed. So in other methods, you instead of putting values of x is equal to 0, x is equal to minus 1, you usually multiplied everything and then found out the solutions using elimination. So when you're multiplying, for instance, say in the term a into x plus 1 into x squared minus x plus 1. If you multiply x plus 1 to x squared minus x plus 1, there'll be one term with the value of x cubed. So x times x squared it'll be x cubed. And that x cubed will always be multiplied with a. So therefore, on the left-hand side, it's always a constant 1, so there is no coefficient for x cubed. It becomes 0. On the right-hand side, for the first term, we have a. So just write it down. Again, for b, if you multiply x to this quadratic equation, you get x cubed minus x squared plus x. So you have b, so plus b. And then when you look at the third part, x times x plus 1 is x squared plus x. So when you multiply cx with x squared, you get cx cubed. So therefore, we'll also have c as a coefficient of x cubed. Now we get this equation, 0 is equal to a plus b plus c. So it's just a simple matter of substitution. C becomes minus a minus b, which is simply minus 1 minus of minus 1 by 3. That becomes minus 1 plus 1 by 3. Putting LCM, we'll get minus 3 plus 1 divided by 3. C has a value of minus 2 by 3. So now you got the value of C. How do you get a value for D? Remember that x times x plus 1 is x squared plus x, and that x squared plus x has to be multiplied with c, x, and d. So if you multiply d with x squared plus x, you'll get dx squared plus dx. And even cx will also have a term cx squared. So basically, to find the value of d, we equate the coefficient of x squared. Let's go back here. So if you multiply 1 to x squared, you'll get x squared. So therefore, we have a as a coefficient. We will also have b as a coefficient when x is multiplied to minus x. So it becomes minus b. But hold on a second. If we look at the part with a, you see x plus 1 times x squared minus x plus 1. It is just the same as x cubed plus 1. So therefore, even if we're able to substitute 1 to x squared and then to a, it would still not work because these two are actually when you multiply these two, you get x cubed plus 1. So therefore, a does not have, so a is not a coefficient for x squared. Let's erase it. So we have minus b over here. Now, what we do for cx plus d, when 1 times x times cx gives you cx squared, again, that's a plus c, and d times x gives you dx squared. So again, that's a plus d. Again, left-hand side, there's only 1 as a constant, no coefficient for x squared, 0. Now, how do we find the value of d? Again, simple. Put the value of d as b minus c, just by interchanging the position. So therefore, now what we get is, we know the value of b, that's minus 1 by 3. We know the value of c, that is minus 2 by 3. Since there's a minus minus, it becomes plus. So minus 1 plus 2 divided by 3. So therefore, you'll get a value for d as 1 by 3. So there you have it. You have a is equal to 1, b is equal to minus 1 by 3, c is equal to minus 2 by 3, and d as 1 by 3. So we know the value of all of the 4 constants. Let's put them in our equation. So 1 divided by x times x cubed plus 1 is now equal to 1 by x plus minus 1 by 3 divided by x plus 1 plus minus 2 by 3x plus 1 by 3 divided by x squared minus x plus 1. So we have simplified this term into partial fractions. Now all that we have to do is integrate them, put the integral sign, put a dx. On the right-hand side, put an integral sign, keep all of these terms under a bracket, and outside the bracket, write dx. Again, the next thing we're going to do is we're going to simplify, basically split the integral along the 3 terms. So over here, integral dx divided by x times x cubed plus 1 is equal to integral dx divided by x plus, but instead of plus, we have a minus 1 by 3 already. Let's pull it out. So minus 1 by 3 times integral of dx divided by x plus 1. And then in this term, which is minus 2 by 3x plus 1 by 3, let's be creative and pull minus 1 by 3 outside. So minus 1 by 3 times the integral of, it'll be 2x minus 1 dx divided by x squared minus x plus 1. So the first part is integral dx by x. So that is integral 1 by x dx. You know the value for that. It is just log x minus 1 by 3 times. Again, if you try to derive x plus 1, you'll get a 1. So basically, this term will now be minus 1 by 3 times integral of 1 by x plus 1 times dx. Again, it'll be a log. So minus 1 by 3 times log mod x plus 1. Then, if you look at the third part, you see that if you derive x squared minus x plus 1, if you consider this as t, then dt will be equal to x squared becomes 2x, minus x becomes minus 1, plus 1 is now 0, times dx, because it was dt by dx, dx comes to the right-hand side. So basically, now this part, the numerator becomes dt and the denominator becomes t. Again, a classic case of adding a log or putting it as log. So minus 1 by 3 log mod t. So we have log mod x. And then let's take minus 1 by 3 common. We will have log mod x plus 1. It'll be minus log mod x plus 1. Or let's make it simpler. Let's take plus 1 by 3 common, so we'll still have the same signs. So it'll be, or wait, actually pulling out a minus is better, because if you pull out minus 1 by 3, then you'll have plus on both sides. Both of these terms will be positive. So we'll have log mod x plus 1 plus log mod, and instead of putting t, let's put the value of t, which is x squared minus x plus 1. Right now, we have the classic case of log a plus log b. And what is the value? It is just log ab. So now let's rewrite it. So log mod x minus 1 by 3 times log mod x plus 1 times x squared minus x plus 1. Again, over here, we have something of this form. So we have a plus b times a squared plus b squared minus ab. So what is the left-hand side for this part? It is a cube plus b cube, x cube plus 1 cube, which will now become x cube plus 1. Now, if you look at this part, 1 by 3 log x cubed plus 1, it is now looking like a times log x. And if you remember a property for logarithm, it's log x raised to a. So that is equal to a times log x. So therefore, we'll get log mod x minus log mod x cubed plus 1, the whole raised to 1 by 3. So right now, we have log mod x minus log mod x cubed plus 1, the whole raised to 1 by 3. Again, classic example of log a minus log b. So the final answer will be log mod x divided by x cubed plus 1, the whole raised to 1 by 3. Because log a minus log b will always be equal to log of a by b. And that is how you get your answer, log mod x divided by x cubed plus 1, the whole raised to 1 by 3, plus c. Again, when we're doing our easy method, you don't need to put c everywhere. Just put a c in the end, because that is the constant for integration, for indefinite integrals. When you're doing definite integrals, there's no value for c. So therefore, it's just for indefinite integrals. So you can just put it at the end. That makes the whole calculation a lot easier. So that is the answer for the integral of the term integral dx divided by x times x cubed plus 1. So this is the answer that we got. We used various properties, partial fractions, etc. in order to arrive at this answer. And that concludes this webisode of Cbse board exams. Integrals is a big chapter, and we have uploaded many videos on the same topic. For accessing more of those, you can always click the link in the playlist that I've put in the description down below to view more videos and more interesting ways of solving. If you'd like to visit more of our useful and interesting content, then don't forget to subscribe to our channel, Brain Blitz Audios. So until the next episode, take care Stay safe. Bye-bye for now.